Assalamu alaikum. This is the third out of 5 short presentations on how to estimate the required sample size for various scenarios. And this presentation will go through the equations for controlled studies with at least two groups, whether independent or matched. We are dealing here with controlled studies with at least two groups of independent samples or matched samples. The outcome is continuous, as if you are, for example, measuring lengths, whether surgical or by imaging or certain pathological specimens, volumes like amount of bleeding, time like survival duration or hospital stay, measuring some vital signs, whether it's blood pressure, oxygen level, pulse, or laboratory findings, whether we are interested in measuring hormones, enzymes, or tumor markers. They are all continuous data, and the formula is the same. This is one formula used for estimating the required sample size for a controlled study, continuous outcome, continuous data. The number required in each arm of the study for each group will depend on three entities. The first relates to how much you can tolerate a type 1 error, alpha. The second, how much you can tolerate a type 2 error, beta. And the third is reflects the effect size, how much difference you would expect between the two groups in terms of their standard deviations. The first entity, by far the commonest level of significance chosen for medical research, is p equal or less than 0.05, and this translates to a z-score for a two-sided study of 1.96. So you see this 1.96 being used repeatedly in several equations. The second z-score is related to the power, and the usual in medical research that we use either 80% power or 90% power. If we use the higher power, of course, then we need more subjects in each group. But if we can do with 80%, then we'll have a smaller n. The z-score for the 80% is 0.84, and the z-score for the 90% is 1.28. So these two figures, you will see them repeatedly used. The 1.96 and either 0.84 for 80% power or 1.282 for 90% power. The third entity is the effect size, and this is basically how much difference you expect between the two groups divided by their pooled standard deviation. The higher the effect size, the less number will be required for each sample in each group, and vice versa. We'll go through how to estimate the effect size in the next two slides. Remember that we are trying to estimate the expected effect size before we start the study. So we don't really know how much of an effect size it will be, but we try to have a good guess about how much it is so that we can calculate the required sample size. There are several ways of estimating the expected effect size. One of them, of course, is to look into the literature for similar studies and see how much effect size is there. Or you can have a personal assessment of this, either by a good guess or by a pilot study, or you could try to think in terms of percentage how much you would think there would be a difference between the two groups, 10% or 20 or whatever. The third is to use the special conventions like Cohen's d for the effect size. Cohen had classified the effect size into 0.2 for a small effect size, 0.3 for a medium, and more than 0.5 for a large effect size. So if you have your thoughts about how much you would expect of a difference between the two groups, if it is small, then the effect size you can choose is 0.2, medium 0.3, and if you expect a large difference between the two, then you can choose 0.5 or more than 0.5. And if you don't want to use any of these three ways, then you can try and estimate the effect size with special formulas. The effect size can be estimated with the usual formula, but remember that we have not yet started the study, so you plug in figures here that you would expect them to happen. You've not seen the results yet. You would have a good guess about what you expect the mean of the first group would be, what you would expect the second group mean to be, and then you try and calculate the pooled standard deviation of the two groups using another formula. And once you have decided on the expected effect size, you can plug it into the equation plus the z-score for the level of significance and the z-score for the power. And this is just an example about what you can expect the effect size to be before starting the study. Say you have two groups here measuring a hormone or an enzyme or a certain continuous output. You expect the mean of the first group to be about 100 and the second group to be about 90, and you will use these two figures in the equation for the expected effect size. The tricky bit, of course, is the expected standard deviation, because that would require the number you would put into each group and the expected standard deviation for each group independently. And you can fill into this equation if you have sort of a rough idea about what you expect the standard deviation of the first group to be and the second group, and how much you think you would need in terms of sample size. And the equation first for the pooled standard deviation would start with the number in the first group, that's 100, minus 1, that's 99, multiplied by the square of the expected standard deviation, which is 20. So that's the first thing, plus the same thing for the other group. 100 minus 1 equals 99, divided by squared expected standard deviation, the square of 15 is 225. Divided by 100 here, 100 there, minus 2 equals 198, and from this you would get a figure divided by 198. This is 312, and you take the square root of this, and it is 17.7. So you take the 17.7, which is the expected pooled standard deviation, put it into this equation, minus the mean. The expected mean for group 1 is 100, and the expected mean for group 2 is 90. So the difference is 10 divided by 17.7, and this will give you 0.56. So that would be the expected effect size. Use this into the formula, and now for the z-score for the level of significance, we use 1.96, and the z-score for the power we use, because we are choosing a 90% power, 1.28, and divide this by the effect size that we have just calculated, which is 0.56, and multiply all by 2. Then you get 2 multiplied by 33.5. That is to say, you need 67 cases in each group. This is the other way of estimating the effect size from an estimated pooled standard deviation if you don't want to use figures from pilot studies or from the literature. So for example, if we are setting up a controlled study for continuous data, trying to see if the systolic blood pressure of patients with epistaxis would differ between adult group and pediatric group, that's group 1 and group 2. And this will be a two-sided test, and we have selected the alpha level at 0.05, that's the usual, and chosen a power of 90%, that's again quite common. And we think that there would be about 10 millimeter mercury difference between the two. This is what we are going to use for the estimation of the sample size. We use the same formula, the z-score for the 1 minus alpha over 2 equal 1.96, the z-score for the power of 90% equals 1.282. The difference between the two groups is about 10 millimeters mercury. We think that this would be the difference between the two groups. We've not measured it yet, and we also expect the standard deviation to be similar to what we found in the literature or what we have found in our pilot studies, to be about 20 millimeters mercury. So we expect the effect size to be about 0.5. So the sample size would be equal to 2 multiplied by the z-score for the level of the significance, 1.96, plus the z-score for the power, 1.82, all divided by the expected effect size, 0.5, all squared. The required sample size would be 83.98. That is the least number of cases. So we need 84 patients in each arm of the study. One other scenario for measuring the sample size for controlled studies, continuous data, is when you are measuring the required sample size for matched samples. Matched samples is like, for example, if you are measuring the same person twice, one before and one after a certain treatment or a certain operation, or you have matched two individuals in any way and trying to see the difference of or an effect of a certain agent on them. So these these measurements are for matched. We are interested more in the difference between the matched couple than in the pooled averages of each group. And for this, what we use in the formula for the effect size would not be the standard deviation, the difference between the standard deviation of this group and that group. It would be the standard deviation of the difference between individual pairs. So for the first pair, for example, the difference is 20 point something. And the second pair, you would find a difference of 15. And the third pair, you would find a difference of 10. And what we will do our estimation of the effect size of based on the differences, the mean of the differences and the standard deviation of the differences. So this would be the mean of the differences rather than the difference of the means, rather than the difference between the two means. We'll be taking the mean of the differences, and the same apply to the standard deviation. It will be the standard deviation of the differences rather than the differences between the standard deviation. And then we'll estimate the effect size, and that would be plugged into the equation as usual. By this, we come to the end on this presentation on the estimation of sample size for controlled study continuous data. The next presentation will be on controlled study dichotomous data to measure ratios, percentages, or proportions. Salaam alaikum.